Hello, students, and welcome to the first week of lectures, the Chem 150 review. This lecture will be broken up into 3 parts, and I'll advise you to try homework problems in between each part. The first will be a review of nomenclature. It's really important that you can write the names of things and the formulas especially, so you can write and balance chemical equations. We'll also talk about solutions. As you start doing lab exercise or lab assignments pretty soon, making solutions is going to be really important in Chem 151, a lot more important than it was in Chem 150. You'll be having to make a lot of your own solutions a lot of the time. And so we want to review that very carefully. Finally, we'll have a little review of stoichiometry, and all of this will prepare you for a homework assignment that will be due at the end of the week. And so if you have old notes from your old class, of course, you're welcome to use those. I'll also kind of point you in the instructions to pages that you could look at in the textbook if you want to review this as well. But mainly, I'm having you rely on my lecture to review this and whatever notes you may have and practice with the homework. Okay, so let's get started. So let's start by talking about naming binary covalent compounds. So binary here means 2 elements. Covalent means that they're only metals and nonmetals. So what's really important when you're naming compounds is that you can identify if they're ionic or covalent, because they're going to be named in a different way depending on if they're ionic or covalent. So we'll talk about which order to write the elements in. We will use prefixes only for covalent compounds. When we move on to ionic compounds, there will be no prefixes. And these will end with the IDE ending, the binary covalence. Okay. So first of all, which order will you write elements in? For example, with CO, as you can see here, it's written CO, carbon monoxide, not OC. And this has to do, technically, it has to do with the electronegativity values. Remember, electronegativity is the strength with which an atom pulls on electrons when it's in a covalent bond, or in a chemical bond. So you can see these numbers here. You don't really need to memorize these numbers. What's important is that you should notice that they get bigger as you go up and to the right on the periodic table. Basically, if an element is more to the left or down on the periodic table, you usually write it first in the chemical formula. If it's up and to the right, you'll write it second. So since C, carbon here, is more to the left than oxygen, you would be writing that one first in the chemical formula. Okay. So CO, not OC. In naming covalent compounds and only covalent compounds, you're going to use prefixes here, only for covalent compounds. So the prefixes indicate how many of each atom that you will have in this molecule, in this covalent compound. So if we have P2O5, for example, this is called diphosphorus, di for 2, pentaoxide, penta for 5. Sometimes people say pentoxide, that's accepted too. But technically it's pentaoxide. So notice that again, we end with "ide" as well, always with "ide" in the binary covalence. There are a few special cases. If you have a single atom at the front, you do not use mono. So for example, notice we didn't say monocarbon monoxide, we say carbon monoxide. And there's also another exception here. Notice we didn't say monoxide, right? I'll get to that in a moment. But we never put mono at the beginning. So no mono here, it was left off. Here, silicon tetrafluoride, not monosilicon, because we don't put mono in front of the first element. And finally, dinitrogen monoxide. Notice we didn't say monooxide. We didn't say monooxide here either. We don't use the double O's with oxide. So that's a special case. Also notice these all end with "ide" if they're binary covalent. So for each of these elements, it goes like this: hydride, carbide, nitride, phosphide, oxide, sulfide, fluoride, chloride, and so forth. name to formula, so you use the prefixes here. So if we say sulfur dichloride, the di means 2, so there's nothing written in front of the sulfur, so we have 1 sulfur, 2 chlorines. Sulfur dichloride. Dinitrogen tetraoxide, N2O4, 2 nitrogens, 4 oxygens, and we ended with ide. This is the brown chemical in smog. Carbon tetrabromide, 1 carbon, 4 bromines. Okay. Naming binary ionic compounds. So in ionic compounds, we do not use prefixes. There will be no prefixes in ionic compounds, only covalent compounds. We'll name the metal first, and then the nonmetal next, and we're going to use ide because the nonmetal is going to be a negative ion with only 1 atom in it. And so its ion name will end with ide. Keep in mind the charges here. You may want to note these on the periodic table that I gave you. In group 1, when these make ions, they always make +1 ions. For group 2 right here, these always make +2 ions. Group 3 metals, aluminum, gallium, and indium, always make +3 ions. Group 5 nonmetals, nitrogen and phosphorus, make -3 ions when they make ions. Oxygen, sulfur, selenium make -2 ions when they make ions. Chlorine, chlorine, bromine, iodine, the halide ions, they're -1. And you should not have that memorized, but you should know why, right? These have 1 valence electron, so when they lose 1, they make a +1 ion. These have 2 valence electrons, so when they lose their 2 valence electrons, they make +2 ions, so forth. So when we do the nomenclature, we're going to have to go from formula to name, also from name to formula. And for covalent compounds, it's all pretty straightforward. For ionic compounds, we got to deal with the fact that we have ions. So there's a little bit more to it. If we're going from formula to name, though, it's not too bad. We write the name of the positive ion, and we write the name of the negative ion. Not too difficult. So for example, sodium chloride is NaCl. And it is this because it has a Na, Na, and that ion is +1, Na. And it has a chloride ion, which is -1. Now, when you write the names of ionic compounds, you just write the name of the positive ion, then the negative ion. For the metal, the positive ion, it's always just the name of the metal, sodium. For the negative ion, if it's 1 atom like this, 1 atom, it always ends with ide. So this is called a sodium ion. Right here, this is called a sodium ion here. This is called a chloride ion. Okay. All the negative ions that have only 1 atom, their names end with ide, and that's why the name here ends with ide. All right. So next, beryllium bromide. So what I want you to notice here, sorry, this laser pointer will not go away. There we go. All right. So here with beryllium, it's got 1 beryllium ion, which is +2, and it's got 2 bromide ions, which are -1. But notice here we say beryllium bromide. We don't say dibromide. Never ever use prefixes with ionic compounds, only with covalent. Here again, aluminum sulfide. No dis or tris here. It's ionic. Potassium oxide. K is potassium oxide here. Magnesium iodide. And so I am going through this kind of quickly because it's mostly a review. But if you do have questions, make sure to come to my office hours, okay? then I can help you a little more. Now, going from name to formula is a little harder because notice here, going back to the previous slide, we already were given how many of each ion there are. The name does not tell us this because these are ionic. We figure out how many there are by making sure that the positive and negative charges cancel out. So, for example, let's say we want to name lithium sulfide. So first we have to figure out, okay, what are the ions? Oh, okay, we've got a lithium ion, Li+. And we know that because it's in group 1. And then we see sulfide. Okay, the ide tells us that it's only one atom, the sulfur. Okay. And its charge is -2 because it's in group 6 of the periodic table. Okay, I can escape from this. Let's keep. Okay, so here we look at our periodic table, our handy dandy periodic table here, and we see sulfur is in group 6, so it's -2. Lithium is in group 1, +1. Okay. All right. And then we have to figure out how many of each we should have. We want to make sure that our positive and negative charges cancel. So for our lithium, we're going to need, one more. This will give us 2 positives to go with our 2 negatives from the sulfide. And now finally we can write a formula. It's Li2S. You can also verify this with algebra, or not algebra, just summing the numbers. We've got 2 lithium ions, each +1 here, and that we've got 1 sulfide ion, -2. Together the charges add up to 0. Okay, and one more example. Calcium fluoride. Calcium is +2. Whoops, I want a laser pointer. I wanted the pen. Calcium is +2, Ca, 2+, and fluoride is -1. So here we've got 2 positives and 1 negative. We can't change the charge here, but we can add another one, F-. We get 2 negatives to go with our 2 positives. So we can see that the formula should be 1 calcium and 2 fluorines, which is what you see right here. 1 calcium, 2 fluoride ions. And remember, these are called fluoride, these negative ions, and this is called sulfide because they're negative ions with 1 atom. For the polyatomic negative ions, they're going to end with things like ate and ite most of the time. So the fact that these are 1 atom tells us that they're ide ions. So up until now, we've only dealt with metals that have only 1 charge. But some metals have more than 1 charge. These are called variable charge metals. So actually most metals are variable charge metals. The only ones that aren't are in group 1, group 2 of the periodic table, group 3 metals, aluminum, gallium, and indium, and then a few more, zinc, silver, and cadmium. So for an example, we're looking at iron. Iron is very commonly found in compounds as a +2 ion. It's also often found as a +3 ion. And so we can have 2 different compounds. FeO is one compound that contains iron. It has a +2 iron, and Fe2O3 is another iron oxide compound. That one, though, has +3 ions. So we need a way to tell the difference between these 2 compounds. It turns out we're going to now add something to the name of the ion to indicate its charge. So for example, with the iron here, here the iron is +2 in the first situation, iron 2+. And the oxide is, oxygen is in group 6, so oxide is always -2. And so this ion here is called iron 2 ion. Iron 2. The 2 here means that the charge is +2. And then this ion here is called the oxide ion. Its name ends with "ide" because it's oxygen, only one atom in the ion. That's why it doesn't end with "ate" or "ite." Okay, and now we can now write the formula here. The formula is FeO. So these were the ions here, one iron ion and one oxide ion. Their charges cancel, so we only need one of each. But notice this isn't called iron 2 oxide because there's a 2 here. There isn't. It's called iron 2 oxide because the iron is +2 charge. Likewise, in Fe2O3, the iron is +3 charge. All right. So, just as a summary here, you'll probably want to note on your periodic table the fixed charge metals, so you know them for later. Group 1 here and group 2, these are +1, +2, and then there's a little triangle on your periodic table near group 3, which includes zinc, cadmium, those are +2, silver is +1. I'll show you where it is on the periodic table real quick. If we go back to the periodic table, so the group 1s here, group 1, all +1, group 2, all +2, group 3, +3, and then here's a triangle. These are +2, silver is +1. Make sure to note that on your periodic table so that you can get know when your metals are fixed charge. Okay. So what if we're going formula to name here? So that was name to formula. What if we're going formula to name? So this is a little bit trickier because we have to figure out what the charge would be here for the cobalt. So we look at this. First we think about, is this ionic or covalent? Well, we know it's ionic because there's a metal in here. And now that we know it's ionic, we now have to ask, now that we know if it's ionic, are we going to have to use a Roman numeral because this metal is variable charge? Well, if we look, cobalt is not a fixed charge metal. It's one of our variable charge metals. So we have extra work to do to figure out what that charge is. Well, we do know that the bromide here is -1, and we've got 2 of them. And we do know that the charges have to add up to 0. So we have 1 cobalt and we have 2 bromides, which each are -1. So if we add 2 to both sides, we get cobalt equals +2. So the charge on the cobalt is +2. So since we know the cobalt ion is +2, we can now call this cobalt 2 bromide. Okay, cobalt 2, not because there's a 2 here, but because the charge on the cobalt is +2. But we do need, because it's a because it's ionic and it's cobalt is +2, it's variable charge, we need to put the 2 here. We calculate the charge in the metal. You can also do this visually if you like. So what I sometimes do is I'll write down, okay, well, usually I do this in my head, but I mean, when you get better, you do it in your head. Some of you maybe already are there if you practice a lot in earlier classes, but here I've written 2 bromides so that I know that their charges add up to -2. that means that I must have 2 positive charges. But I've only got 1 cobalt to put it on. So my cobalt must be positive 2. Because I had 2 positive charges. I knew I had 2 positive charges because from the bromides together I had 2 negative charges. Okay. Here's another one. Again, the charges add up to 0. So here we have 2 coppers. We have 2 coppers and 1 sulfide. So the sulfide is group 6. Its charge is -2 because it's in group 6. And we have 2 coppers, and I'm going to call the charge of the copper X. So we have 2 times X plus 1 times -2, so -2. We add 2 to both sides, then divide by 2. We get X is +1. So n here. So the formula gives you how many of each atom. The charge on the negative ion is, well, it's in group 6, so it's -2. So we could do this visually like I showed the other one too. 2 negatives here, right? And then we have copper, we have 2 of them, but we don't know what the charge is. But what we do know is altogether we've got 2 negatives from the 1 sulfide. We must also have 2 positives. So one of the positives goes here for a +1 here, and then the other goes right here for a positive here. And so it's 1 positive, so we call it copper 1 sulfide. Again, the 1 does not mean that there's 1 copper in the formula. What it means, see there's 2 here. What it means is the charge of the copper is +1. Here's one more. This is going from name now to formula. From name to formula isn't as bad. So if we have the name, for example, nickel 2 iodide here. Well, nickel is +2. We know because it says 2 here. Remember, the 2 means that we have a +2 charge. And the iodide is -1. So if we have 1 more iodide, that gives us 2 negatives to go with our 2 positives. So finally, the formula is NiI2. One more example here, iron 2 nitride. Okay, another name to formula. Well, iron 2 means that we have an iron ion with a +2 charge to it. And then nitride, the "ide" here tells us that it's a negative ion with 1 atom, and the nitr means it's a nitrogen atom. It'll be -3 in charge, and now we have to make sure that our charges cancel. We've got too much negative, not enough positive. And so we can add another iron 2+. Remember, we can't change the charge. We have +2 ions here. We can't change the charge. What we can do is add more of them. Now we can add another nitride rather, here. And this gives us 6 negatives. If we add 1 more iron, this will give us 6 positives to go with our 6 negatives. And so we can write finally 3 irons, 2 nitrides. And we can also check, do the charges add up to 0? Yes, we've got 3 +2 charges, each from the iron, and 2 -3 charges. So +6 minus 6 adds up to 0. So this is the formula, Fe3N2. Finally, you'll also have to deal with polyatomic ions, particularly polyatomic negative ions. We've been dealing with only monatomic negative ions, and notice they've always ended with "ide." Their names always ended with "ide." So now when we get to the polyatomic ions, many of them end with "ate" and "ite." So that's how you'll be able to recognize them. There's a list of the ions on Canvas. I showed you where that was in the top in the syllabus and info. So you want to have that beside you, and you need to have those memorized, really. Otherwise, your life is going to be extremely difficult. Generally, when we do in-person class, I can enforce that you have these memorized. I don't provide them to you on exams. Now, I can't really enforce that, but it will be hard for you to follow anything that we're doing if you don't have the polyatomic ions memorized. You should have those memorized. The variable charge metal rule still applies. If you have a variable charge metal, the metal ion will have a Roman numeral with it. Watch out, there is one positive polyatomic ion that's common here. It's the ammonium ion. So you'll want to make sure you watch out for that one. So let's name a few examples. I won't do all of these. I'll leave some of them for you to practice if you take a look at this video. So I'll do the first couple, and then I'll skip them. The answers are shown later in the video. Okay. Sodium phosphate. Or, well, I said the name. So name these examples. So how did I know that? Well, first of all, I've got 3 sodiums. Sodium, we look at this, we say, okay, this is ionic because sodium is a metal. You should know that from your periodic table. It's way on the left side. And so it's not variable charge because it's in group 1. So we don't have to do Roman numeral. We can simply call this sodium. So, and then we see a PO4. And so we would look at our list of polyatomic ions. So if you've got that with you right now, go ahead and take a look at it. Or you can, if you put PO4 into Google, I'm sure it will tell you phosphate, because it will know that you're trying to talk about the PO4 3- ion. We would call this sodium phosphate. Here, this one, I'm going to let you try that one. Okay. So you may want to, I'm going to tell you to pause the video after this to try this. I want to do this one for you though. Okay, so for this one, it's ionic, and we've got a variable charge metal. It's iron. It is not in our group 1 or group 2 or in our little triangle. And so we'll have to figure out what the charge is. Well, the way we do this, whenever we do it, is we write out the ions. We see CO3. This is clearly polyatomic. It's not a single atom. And so its name is not going to end with "ide." We'll have to know the name, and we'll have to know the charge as well. So the charge, the ion itself is CO3 2-. It's carbonate. We've only got one of them, so we know we got 2 negatives, which means that our iron must be +2 for the charges to cancel, since we have one of each, 1 iron, 1 carbonate. So now we can finally write the name. It would be iron 2 carbonate. And there's one more problem for you to try here. I'm gonna leave those 2 up to you. You may want to pause here and give them a try. The answers are on the next slide. Okay, you've unpaused. We'll show the answers. They were sodium phosphate, calcium hypochlorite, iron 2 carbonate, and copper 2 hydroxide. Now going from name to formula. So here we'll have to write out the formula. Again, just as before, you write out each ion with their charges. You figure out how many of each you would need to cancel the charges. The new thing here is if you have a polyatomic ion, if you have more than one, you use a parentheses to indicate that there's more than one. If we go back here, this parentheses 2 meant there was more than one hypochlorite here. There was 2 of them. And here the 2 meant there were 2 hydroxides. Okay, and so now here's some examples. Aluminum sulfate. So we should ask ourselves first, ionic or covalent? This is ionic, and the metal is aluminum. Aluminum is a fixed charge metal. It's in group 3, and so its charge is going to be 3+. Aluminum positive 3. Whoops, aluminum 3+. And sulfate here, you have to have that one memorized or be able to look it up on your chart, but you really should have it memorized. It's SO4 2-. Okay. And so we have 2 negative charges and 3 positive charges. We'll want more negative charges, so we can add a sulfate. And we'll want more positive charges now because we have 4 negatives, 2 and 2 here. We only have 3 positives, so we add another aluminum. And finally, here we need more negative charges because we have 6 positives and only 2 negatives, so we add another sulfate. And so this is our work here. This should not appear anywhere in your answer line or anything like that. It's your work. Our final answer is that we've got 2 aluminums and we've got 3 sulfates. So we do in parentheses SO4, and then we put a 3 on the outside. And that is our answer. Okay. And I'll do one more with you. I'll do I'll do this one, chromium 3 bicarbonate. Okay, so this one is a variable charge metal, which is nice. It tells us what the charge is. So charge is 3+, right? Charge is 3+. We know that because it says chromium 3. 3 means positive 3. So the symbol for chromium is Cr. Say Cr 3+, and bicarbonate is HCO3 -1. Gotta have that up here. So we've got 3 positives and only 1 negative. We're going to need 2 more of these to cancel the charge. 3 negatives altogether, 3 positives from the 1 chromium. So finally our formula is Cr HCO3. That's our answer. This is just scratch work. So at this point you may want to pause the video, give yourself a chance to try the other 2 that I didn't do, the magnesium nitride and the cobalt 2 oxalate. Okay, you pause the video. Here are the answers for you, so you can check your answers. And if you're not getting the right answer, maybe you should see me at office hours. Okay, and I can explain it to you further. Okay, one last type of compound to name: acids. So acids, you'll recognize them because they have an H in the front. Like this one, HCl, H2SO4, H3PO4. Acids behave like ionic compounds. We're going to be talking a lot about the behavior of acids as we move forward in this class, but a lot of acids, particularly strong acids, completely separate into ions. The positive ion for acids are always the H plus ion. And the negative ion is varies. So for that reason, acids will be named based on their negative ion or their anion, because the positive ion is always the same. So acids are always named based on their anion, the negative ion. So if the anion name ends with ide, IDE, the acid name will follow the pattern hydroic. So you know that most negative ions that end with ide, they end with ide because they're monatomic. They have one atom. Like HBr is composed of H plus and Br minus. Br minus is called bromide. So HBr is called hydrobromic acid. HCN has the H plus ion and a Cn minus ion. Cn minus is one of the few polyatomic ions whose name also ends with ide. But since the name of the ion ends with ide, HCN is called hydrocyanic acid, hydroic. If the negative ion's name ends with 8, so if it's a polyatomic ion that ends with 8, name ends with 8, name will end with ic acid. So HNO3 has the H plus 1 ion and the NO3 minus ion. This is called nitrate. So HNO3 is called nitric acid. No hydro. Hydro is only if the anion's name ends with ide. HClO4 has the H plus 1 ion and the perchlorate ion. The per stays here. The H becomes ic in the acid name, and we call HClO4 perchloric acid. Now note that there are some weird exceptions when it comes to sulfate and phosphate. So with H2SO4, it's got two H pluses because sulfate is -2, so it needs two H pluses to cancel the charge. And SO4 2- is called sulfate. So H2SO4 is sulfuric acid. Notice it's not sulfic acid. The 8 isn't directly replaced with ic. The UR stays. The same for phosphoric acid. It's not phosphic acid, it's phosphoric acid. Those are the two weird exceptions there. If the name ends with ite for the anion, the negative ion, it's a polyatomic ion that ends with ite. The acid's name ends with us. So HNO2 has an NO2- ion in it. That is called nitrite. And so the name of the acid HNO2 is called nitrous. HClO, that has H plus ion and, not ClO4, ClO. That's called the hypochlorite ion. So this 4 shouldn't be here. And so HClO is hypochlorous acid. Because the name ends with ite, the acid name ends with us. And we have the same exception with sulfite here. So H2SO3 has a sulfite ion in it. Its name is sulfurous acid, not sulfus acid. That UR stays. So in summary, ionic compounds, covalent compounds, and acids are named differently. So make sure which you're trying to name first. Decide if it's ionic or covalent or acid. If it is ionic, check the metal to see if it's variable charge or fixed charge. If it's variable charge, you're going to have to determine the charge of the metal and use a Roman numeral to indicate that charge. If you're going from formula to name. Finally, acids can be recognized by the fact that they have an H in front. So their names are based on the negative ion that they contain. Okay, and that's the end of the first week lecture about nomenclature. I'll have a couple of more half an hour-ish lectures on other Chem 150 review topics after that you'll check out after this. For now, what you'll want to do is start doing part 1 of the homework. Part 1 of the homework is all about nomenclature. And make sure to let me know if you get stuck. And I'll see you on the next video, which will be about solutions.